Hello friends, welcome back. Hearty welcome to you. In the last session we learned how to find out the integral of a function. So let's try to place at a one particular spot all the derivatives and the integrals. So since we know the derivatives, let's go back and write down the integrals of all the functions. For that we'll start with the derivatives so that it's very easy to write down the integrals. We'll write down all the formulas. Let us say the first formula will be d by dx of x to the power of n plus 1 by n plus 1 is equal to x to the power of n. That gives me the integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus constant. Similarly, d by dx of x is 1. That gives me that integral of dx or 1 into dx equal to x plus constant. Let's do some trigonometric functions now. Let us say d by dx of sin x is equal to, we know that it's cos x, so that gives me integral of right hand side, that is cos x, is equal to sin of x plus c. Similarly, d by dx of minus cos x is equal to sin x. I can say derivative of integral of sin x is equal to minus cos x plus c. Because we know derivative of minus cos x is sin x, I can go and say integral of sin x equal to minus cos x plus c. Let's do some more. We know derivative of tan x is secant square x. I can say d by dx of tan x is equal to secant square x. So I can write down integral of secant square x dx is equal to tan x plus c. Similarly, d by dx of cot x is equal to, we know that this is nothing but equal to minus cosecant square x. So I can say integral of cosecant square x dx is equal to minus cot x plus c. Similarly, we know that d by dx of secant x is equal to secant x into tan x. So we can say integral of secant x tan x dx is equal to secant x plus c. The last one we have in trigonometric functions, that is d by dx of cosecant x. We know the derivative is negative cosecant x multiplied with cot x. So I can say integral of cosecant x cot x is equal to minus of cosecant x plus c. Now I will give you one simple method to find out where you will have negative in trigonometric functions. Remember, if your answer is starting with c for the integral, then you will have a negative. You can check that. If you have d by dx, suppose you take integral of suppose let us say sin x, the answer is cos x starts with c. Whenever you start with c, the sign will be negative. That's an easy way to remember. Integral of sin x is cos x, yeah, c, so negative cos x plus c. Similarly, integral of cosecant square x is cot x, but c starts with c, so negative cot x plus c. Similarly, integral of cosecant x cot x equal to cosecant x, we know that, but there will be negative because it's starting with c. That's an easy way to remember. That's not exactly why it is, but to remember, if you are having your answer starting with c in trigonometric functions with respect to integrals, then you will always have a negative sign accompanied by that. Now let's do little bit of inverse functions, integral of inverse functions. We know that d by dx of sin inverse x is 1 by root of 1 minus x square. So let's write it down. D by dx of sine inverse x is equal to 1 by root of 1 minus x square. That gives me integral of 1 by root of 1 minus x square dx is equal to sine inverse x plus c. Similarly, d by dx of cos inverse x is equal to minus of 1 by root of 1 minus x square. That also gives us that d by dx of cos inverse x is minus 1 by root of 1 minus x square. So we can write dx by square root of 1 minus x square also equal to minus of cos inverse x plus c. So remember this. We can write integral of 1 by root of 1 minus x square as sin inverse x plus c or minus cos inverse x plus c. Similarly, we know d by dx of tan inverse x. D by dx of tan inverse x is equal to 1 by 1 plus x square. So we can write down integral of 1 by 1 plus x square equal to tan inverse x plus c. On the same lines, we also know d by dx of cot inverse x is minus 1 by 1 plus x square. So we can also say integral of 1 by 1 plus x square equal to minus of cot inverse x plus c. Similarly, we have d by dx of secant inverse x is equal to 1 by x into root of x square minus 1. So we can write integral of 1 by x into root of x square minus 1 equal to secant inverse x plus c. Also, we know that d by dx of cosecant inverse x is equal to minus of 1 by x into root of x square minus 1. Therefore, we can also write 1 by x into root of x square minus 1 integral as minus of cosecant inverse x plus c. That's about the inverse functions. Let's move to the other functions we have. Exponential function. We know that d by dx of e power x is equal to e power x. So we can say integral of e power x dx. If I forgotten dx here, apologies for that, is equal to e power x plus c. Similarly, we have d by dx of log x is d by dx of log of mod x is equal to 1 by x plus c, or can I say integral of 1 by x dx is equal to d by dx of log x is 1 by x, we know that. So integral of 1 by x dx by x is equal to log of same formula we are following for all of them. The last one we have, that is d by dx of a power x is equal to a power x into log a. I can say integral of a power x dx is equal to a power x by log of a plus c. These are the generally used formulas for integrals or antiderivatives. So let us do some problems using that in the next session. Let me do at least one simple example in this, so that we'll go ahead and try to do the remaining in the next. Okay, let's take a simple example. Let's look at this example where I try to club all the information whatever we learned just now. Okay, now we have to find out integral of this whole function dx. Now one of the properties of integrals, which are general properties, is you can separate them as different integrals. So can I go ahead and write it as integral of x to the power of 4 dx plus integral of cos x dx plus integral of e power 2x minus integral of a power 3x. So we know the integral of x to the power of 4 is nothing but x power n plus 1, n this is n plus 1, so x power 5 by 5 plus, we know integral of cos x is nothing but equal to sin x, because derivative of sin x is cos x, so we know integral of cos x is sin x. I can write that. Next we have to find out integral of e power 2x, so we have to look for the function whose derivative is e power 2x. That's nothing but equal to e power 2x divided by 2. So remember, whenever we do chain rule, e power 2x, in derivative we will do e power 2x is e power 2x into derivative of 2 power x is 2. In differentiation we will multiply, whereas in integration you have to divide. Then only when you take the combination of them it will cancel out. Minus. Okay, next let's go to the next one. A power 3x is a power 3x. Applying the same logic, in differentiation you have to multiply a power 3x into log of a power 3x is equal to a power 3x by log a. So plus a constant to add to all that. So integral of x power 4 is x power 5 by 5. Integral of cos x is sin x. Integral of e power 2x is e power 2x by 2. How we got this? Let me just try to explain you. Okay, let us say now I need to have a function d by dx of f of x is equal to e power 2x. Okay, now suppose I take e power 2x here, the derivative will be 2 into e power 2x. So I have to take here d by dx, let us say I took e power 2x, that will become 2 e power 2x into derivative of 2x. That's nothing but equal to 2 into e power 2x. But what we want is only e power 2x. That means my f of x should be e power 2x by 2, so that I can cancel the 2 and say that's nothing but equal to e power 2x. So that's how we got e power 2x by 2. Applying the same logic, you will have a power 3x by log a. So in the next session we'll try to solve simple examples related to the integrals. Thanks for your time and support. Bye for now.